Thank you very much. I want to thank you all for turning out on a rather dreary day. This is like the day that last year when I gave a talk on the Salem witchcraft trials. And that's kind of where I've got started into this topic, because I began to look at the intellectual currents and the scientific knowledge in New England at the time of the Salem witchcraft trials. And that led me into looking, as you'll understand, how I got into alchemy, because it turns out that there were a lot of alchemists in New England in the 17th century. Let's start by looking at some of the prevailing scholarly views of alchemy. Some historian, this is mostly from the 50s and 60s. It's referred to as mystic science, pathology of thought, the greatest obstacle to development of rational chemistry. It is, obviously it's some sort of weird pseudo-scientific kind of thing. Carl Jung even took it even further. If you get down here, he's basically saying that he's all of these changes and the observations of the alchemists were really projections of inner states, and they had no real reality. Jung was probably relying on a work that he was familiar with from the 19th century alchemist. By that time, the term alchemy was taken over completely by these occultists, people who were interested in esoteric knowledge. And the rational part had gone in its own way and become chemistry.
Walter, I hate to interrupt, but he uses the word psychic. And does that mean psychic as we describe it?
To some extent, yeah. Jung is he believed in those kind of projections, and he believed in collective unconscious and those kind of concepts. Yeah. In its own time, but from its contemporaries, it got a bad press. Just some examples. Pope John the 22nd issued a papal bull against it. Okay, well, basically against falsification of gold. Geoffrey Chaucer in the Canterbury Tales has a story about a fake alchemist who gulls people as a confidence man. And that's from the 1380s. And then Ben Jonson, The Alchemist, a famous play which revolves around a charlatan who is gulling people for money. So it got in its own time, it often got bad press. People, of course, given that, as you will see, that there was such a large number of people involved in alchemy, invariably there'd have to be some bad actors. You certainly it couldn't be otherwise. On the other hand, talk just about this. We're going to kind of focus a good bit on the 17th century, because we know a lot about the alchemists then. We have even some of their original documents. But these are people who are seriously interested in alchemy. Isaac Newton, Robert Boyle, John Locke, okay, Gottfried Leibniz, co-discoverer of calculus, Baruch Spinoza, okay. These are heavy hitters. They take it seriously. They're very interested in it. In the case of the first two, Isaac Newton and Robert Boyle, they're actually laboratory practitioners. And Isaac Newton in particular, in a very big way. When you look at this, you sort of say, we got these historians of science in the 50s and 60s, they're just dismissing this. They know better than Newton, one of the top scientists in the history of the world. Maybe we ought to rethink this and see if we can understand what these people are actually trying to do, instead of just dismissing it out of hand. Now, we'll talk a little bit about Newton's alchemy. It was known for many years that Newton would go away usually about 6 weeks at a time, spring and fall. He would go to his laboratory and he would just work, okay, on alchemy. He'd drop everything, he'd go off and he'd work, and he would do, be round the clock doing experiments, keeping his furnaces going and so on. Now, in the 1930s, I think it was descendants of Newton's niece had boxes of his papers. Now, some of it involved his writings on religion and theology, which apparently a bishop looked at and said, "Oh my God, it's heresy." He was a Unitarian, by the way. He was an anti not the bishop, but Newton did not believe in the Trinity. Okay, which is ironic because he was at Trinity College at Cambridge. Bit strange. By the way, that's probably one of the reasons he didn't go further in the university administration, because he would have had to make a declaration of belief, and he couldn't have done that in good conscience. In any case, this alchemical notes were auctioned in the 1930s. It's estimated that Newton wrote about 1 million words on the topic, and that's not trivial. Okay, that is a serious interest. John Maynard Keynes, the great economist, was able to acquire 85% of the auction documents. Keynes expressed the idea that Newton wasn't the first scientist, he was the last magus, he was the last magician, in the sense that people understood in antiquity. That means about 15% is still out there in private hands and hasn't really been examined by scholars. Now, between the 1930s and reassembling a lot of these documents, nothing much happened. People really didn't go in there and dig into it in any great depth. Then in the 1970s, historians of science began to really look at the notes in depth and began to uncover really fascinating stuff. That resulted in a number of scholarly articles, but also a book that you might want to pick up, Betty Jo Teeter Dobbs's Foundations of Newton's Alchemy, or The Hunting of the Green Lion, talking about in detail what Newton was up to in his alchemical work.
Yeah. Could you give a definition of alchemy, because I'm a little lost on...
Well, alchemy, I'm going to talk about what alchemy did in just a second, what it consisted of, and the worldview of the alchemists. Okay, if you want the most common definition most people adhere to was that alchemy was a laboratory practice that attempted to convert base metals into gold by chemical means. Okay, it actually means a lot more than that, but if you were to look that up in most dictionaries, look up it online, that's probably what you'd find. Okay. After Dobbs's book, there's been a tremendous volume of scholarly articles and books on the subject of alchemy, reassessing it, primarily focused on the 17th century, which is the period of the scientific revolution. And I mentioned listed some of the major players here: Lawrence Principe, who's at Johns Hopkins, William Newman, who is now at Indiana University, used to be at the Department of History of Science at Harvard. I was kind of interested because that meant that he was right below where I used to, in the lower level of the dormitory I used to live in. So that I should have tripped down there and taken a look at what they were doing. Bruce T. Moran is also he's at the University of Nevada at Las Vegas. These guys have been producing a lot of very deep scholarly work. They're looking carefully at this. The picture there, in case you're interested in what that is, that's actually what's called the star regulus of antimony. If you can isolate antimony from its stibnite ore, and then you can cast it like this, and if you do it a certain way, you get these very nice little crystal formations on the surface. And Newton spent a lot of time, working on ways of getting that star regulus, of producing that effect. One of the things that characterizes a lot of Principe and also Newman, they have the idea, let's look carefully at these alchemical recipes. We may have to translate them because they're often in coded language. And let's go into the laboratory and see what we can do with them, see if they actually work. Just dismiss them because we say, well, that's chemically impossible. Principe gives an example of a recipe for somebody taking stibnite ore, which is antimony sulfide, and going through a series of steps, and then you wind up with a red liquid, which is sweet and can be used as a medicine. And he says, well, there's no way in today's chemistry you could do that. And he actually, he started off trying. He tried getting a reagent grade antimony sulfide and going through the various steps with reagent grade materials. Didn't get the results, didn't observe the color changes and so forth. And finally he said, get stibnite ore. Let's get the actual ore, what the alchemist would have been working with. Then everything occurred just as the alchemist said. What he got at the end isn't any compound of antimony, but is in fact, it's actually ferric acetate. That's why it's red. Tastes sweet. Acetate compounds tend to, they tend to taste sweet. So, and it wouldn't have been a very helpful medication, but it wouldn't have been harmful, like taking, antimony is toxic. It's related to arsenic. So, it was a case where, let's look at what the people are actually doing, and let's see what happens. And we find out that we can verify a lot of their observations, and we can make their recipes work. It's just that their interpretation is different from, their interpretation is different from what our interpretation would be. Okay, let's get just a very short history. This is a very potted history of alchemy. Really starts in Greco-Roman Egypt. The legendary founder is Hermes Trismegistus, Hermes thrice greatest. He's the legendary founder and also the legendary source of a whole bunch of tracts on esoteric and occult writings. He's, by the way, is the source of what's called the Emerald Table, or Emerald Tablet, supposedly found by, according to legend, by Sarah, the wife of Abraham. It was when she entered Hermes' tomb, found this, clutching this tablet that had this text on it. Supposedly he had the secret of eternal life, which is a little bit ironic. It's clutching the hand of somebody who's dead. But, okay. Zosimus of Panopolis is one of the first alchemical writers. He got a lot of recipes for making base metals look like gold, putting coatings on them, making imitation gems. Somewhere between him and the later alchemical writers, somebody got the idea, if we can fake it, maybe we can do it for real. Okay. The Islamic world took up after the fall of the Roman Empire, and they took over that part of the world. There are a lot of Islamic alchemists. These are some of the most prominent ones. Jabir ibn Hayyan. I should put quotations marks around him. He supposedly wrote a couple of thousand treatises. He was a physician and an alchemist. He's a front for a Shiite sect that he was kind of the founder of it, and so they wrote all their works and then put his name on it. However, his most important work, as far as Europe is concerned, the Latin West is concerned, is something he didn't write. Apparently, there's now claimed that it was actually written. There was never an Arabic original for that particular work. You have these others. You have Razi's Avicenna. The Islamic alchemy gets transferred to medieval Europe. We can put a precise date on it. 11 February 1144. That's the day that Robert of Chester finished the first translation of an Arabic alchemical text into a European language. It was at 5 o'clock in the afternoon after he'd had tea. We can be very precise about that. We know exactly when that happened. Okay. There was a period of time where the Europeans had to decide, does this knowledge comport with Christianity? It has pagan origins. We know this is coming from the Greco-Roman world. It's coming through Islam. Can we really adopt this? Is it safe? Eventually you decide, yeah, it is. And then you have, some other people that, many of these just writers, and some of them probably didn't really write the things that they're attributed to. I've got Paul of Taranto. He's the pseudo-Jabir. He's is supposed the actual source of the most important work of Jabir. He's probably a pseudonym anyway. Roger Bacon is certainly real. He actually advised the papacy on some alchemical matters. We'll talk about John of Repus-Sissa because he is one of the people that suggested not focusing so much on transmutation of metals, but production of medications. Raymond Lull, the alchemical works that are attributed to him, and also of Arnold of Villeneuve, and Flamel as well. All of these are people, they're names are attached to important alchemical works, but they didn't write them. They almost certainly didn't. Ripley is real and actually was writing to King Edward IV of England and suggesting, well, you really need to get, put some money, support alchemy, give us some of your support so we can start doing some of these experiments. In the Renaissance and early modern period, you have Agrippa, Cornelius Agrippa, who's very much into the esoteric, secret knowledge of the universe kind of thing, not so much laboratory oriented. Paracelsus is one of the weirder characters. You notice he didn't live very long. He died of alcoholism. One of the founders, however, is credited being one of the founders of toxicology. He was very much opposed to the prevailing medical theories, the Galen humors theory that you had a disease because your humors were out of balance and you had the medications balance the humors. He was advocating using alchemy to produce medications, and that became a very important strain. He was pretty much in his own lifetime was disregarded, hated, despised, chased from place to place. Later, people would advertise themselves as, I am a Paracelsian, I'm a follower of Paracelsus and his ideas as far as medicine goes. I think some of the doctrines of homeopathy come ultimately from Paracelsus. One of the things that was good is he was in favor of very small doses of medicine. So the stuff that he was making, if it was really poisonous, it probably couldn't harm you that much. Okay. Another one who was very much into the esoteric philosophy side of things, believing that the knowledge, you get secret knowledge of the universe, was John Dee, who was an astrologer, alchemist, and advisor of Elizabeth I. You may recognize Tycho Brahe, the astronomer. He had a research facility, Oranienburg, and he had an observatory. He also had an alchemical laboratory where he puttered away. A Polish alchemist, Syndevogius here. All of these contributed in various ways. We had writings, some of them, some of the writings very important, some of the ideas very important. Certainly that's the case of Paracelsus. There's a big impact of alchemy. The degree to which it permeated European culture is really hard to appreciate now because most of the histories kind of gloss over this. The interest in alchemy transcended class. You went from the artisans in the laboratory to the rulers. Now, of course, a lot of the rulers were interested because the prospect of making gold they were really interested in that. They could become wealthy, run their governments. This was a period when there was an acute shortage of precious metals in Europe to make coinage, and you have a precious metal-based economy. Even as late as the 19th century, the United States caused several Indian wars because we needed to go mine silver, we needed to go mine gold, so that we could pay off the national debt from the Civil War. But in particular, Edward IV. How many of you have seen the series The White Queen, or familiar with the novels based on that? Well, he's the king right at the end of the Wars of the Roses. He has an extensive alchemical library, so he has some personal interest, although not active. Charles II, he establishes the Royal Society. He has the head of the Royal Society build him an alchemical laboratory in Whitehall, underneath his bedroom with a secret passage. You can go down there. I thought that was usually where you kept your mistress, instead he has an alchemical laboratory. He kept his mistresses elsewhere, which he had a substantial number. It transcended gender. Isabella Cortese, that may be a pseudonym, that may not be a real person, might not actually be a woman, but certainly was held out to be a woman. She wrote what was a book of secrets. It's called I Secreti. And it's a book of a lot of household secrets, how to get stains out of things, but it has a lot of alchemical recipes in it. And I should mention that that's a very important strain of publication in the Renaissance, early modern period. People writing, trade secrets, how you do things. That's really important even today. You can walk to the newsstands and see the new popular science, they have a how to make anything, that sort of thing. You can go online and get this kind of information. That's now where we put it. We don't know whether she really did anything, but we know that Rebecca Vaughan worked with her husband. They were a team of alchemists. Her husband Thomas, they worked together, and he wrote up the results, and he ascribed a lot of the discoveries to her. And when she died, he wrote a very, very touching remembrance of her and what she contributed to their mutual work. It also transcended religion. Sir Kendall Digby was Roman Catholic. John Allen was a radical Protestant minister. He was educated at Harvard. He's a roommate of somebody I'm going to mention in a short time. But, so it goes, from all extremes, top to bottom. Everybody's interested. It permeates a lot of culture. So it's very important from terms of the intellectual context of everything that's going on in the early modern period. Concepts. We still have the concepts lingering on. We have philosopher's stone, elixir of life. We have the language, alcohol, alkali. There are a lot of alchemical terms that still persist in European languages. It showed up in literature. The Gawain poet is the poet who wrote Sir Gawain and the Green Knight, which is based partly on the Grail quest, but it has a substantial amount of alchemical symbolism in it. Henry Vaughan, which is Thomas Vaughan's brother, was a poet. He wrote a number of poems with alchemical themes, as did John Donne, very famous English poet. William Shakespeare has alchemical themes running through his play Tempest. Okay? Not surprising, really. Even if he didn't really believe in alchemy, you'd probably use something like that because it's part of everybody's way of thinking. In music, alchemist Michael Mayer, I have to make sure I say that rather than Michael Meyer, after the evil character in Halloween. He wrote, it's a musical composition which encodes an alchemical recipe. And this is actually the title page from Atalanta Fugens, which is Atalanta fleeing, about the legend of the race between Atalanta, and I'm trying to remember what the other mythological figure, but she's supposed to...
Meleager?
Yeah, right, exactly. And he wins by he drops golden apples and she stops to pick them up. Okay. Obviously, the symbol is the gold is obviously important. Okay, he's going to use that as a motif. Okay, and of course, in the imagery, some of it's fairly staid. You got the moon, which stands for silver. You got the sun, which is gold. You got all the alchemical apparatus. Over here, it gets a little bit more flamboyant. He's putting a salamander in a fire. I would think this is a Girl Scout picnic. He's making salamores or something like that. But it actually says the salamander lives in fire. If you remember your Latin, okay, and it is changed to the optimum best color. This, by the way, says this is the 10th figure in a series of figures. So. This kind of flamboyant, this is the stuff that Jung thought was, people dredging up from the depths of their psyche and from the collective unconscious. Some other stuff, as we go along, we'll see some others. Paintings, there was a whole genre of paintings of alchemists in their laboratories. An Italian artist named Bega did a lot of these. I often show how really disorderly these laboratories probably actually were. Okay. So that's actually one of Bega's paintings right there. Okay, you can see it's kind of it's a little dark, unfortunately, but you can see it's pretty disorderly. It's not like you'd see right now in most chemistry laboratories. At least I hope not. Okay, well, what did alchemists aim to do? Well, they were very much into elemental transmutation, taking base metals, turning them into gold. Okay, that was where it really started. But then they got into preparation of medicines. We go through all these various processes. We can produce metals. Many of the medicines metal-based. Okay, the tartaremetic and stuff like that. So yeah, we can refer to this as iatrochemistry. And Paracelsus said, all of alchemy basically consists of separation and purification. We have to separate things out, we have to purify them in order for them to have any kind of efficacy. And so the methodology of the laboratory methodology of alchemy focuses very much on separation and purification. And they develop a whole battery of processes, and we'll talk about those a little bit in a moment. The whole battery of processes for separating things away from their contaminating materials, purifying things. Okay. Their worldview in general was that they were dealing with the secrets of nature, things that were really deep, that really, if you understood it, you really understand how nature worked. By the way, that's a picture, that is an 18th century painting by Joseph Wright of the alchemist Henning Brand discovering phosphorus. One of the alchemists actually discovered the element phosphorus. He isolated it from very copious amounts of urine. That's not the kind of experimentation I would find particularly pleasant. Okay, that they were dealing first of all these secrets were known to humans in the past. They were ancient knowledge, and then because of the fall of man, much of that information was lost, and so they're digging back. So they have a lot of respect for ancient writings, and they're digging into those to find information. This was sometimes referred to as the Prisca Sapientia. They also very much emphasize secrecy for a variety of reasons. One is that they're often dealing with trade secrets, how to make particular medication, how to purify gold or something like that. It was also dangerous if you thought you could actually make gold. You wanted to be, if you let people know about you want to be very secretive, because there were cases of alchemists being kidnapped by rulers and then held until like if you go and spun straw into gold sort of thing. I mean, that got maybe kind of based on that concept. I mean, it's kind of hard if you really can't make gold. Okay. But for safety, you wouldn't want to tell people that you had some of these, you wouldn't want to cover them up if you could. Also, you didn't want to expose a lot of this information to hoi polloi, people that really weren't worthy of the information. And that's part of it, that many of these alchemists believed that there was a spiritual side to it, that you had to prepare yourself to receive the information. So it had, so there was a kind of internal transformation, or an internal transmutation that had to take place in order for you to be successful with the great work, which is the transmutation of elements. And by the late, in the 17th century, a lot of the alchemists were, saw this. Well, this is what, how, Francis Bacon talked about science aiding mankind. Well, we can aid mankind. We can make a lot of new things. We can make new medications. We can make new substances. And I'll point out that there's this alchemy always had this intense artisanal component. It makes things. As one historian of science said, it wasn't something you believed in, something you did. And that's really true. And that is continued all the way through into modern chemistry. You can't get a degree in chemistry anywhere in the world without learning how to make things. Sophomore organic chemistry, the whole course a laboratory part of the course is devoted to synthesis of organic compounds. You learn how to make things. There are whole journals, like the Journal of Organic Chemistry. It's all devoted to how you make things. Okay, so that continues, that artisanal aspect carries over all the way into modern chemistry. Okay, this is from the Emerald Table, the Tabula Smaragdina. That's the actual, I think it's the Latin word for emerald, actually. That which is below is like that which is above. By the way, I took this from the translation of the Emerald Table by Isaac Newton. He had a copy of it. He translated it out of Latin. Okay. Some of the alchemists, but not all, believed that there was a connection between the heavens and the earth, and alchemy and astrology went together. And you can see that in kind of the symbolism. These are all the known metals, okay? And they're associated with astronomical bodies, gold with the sun, and that's the symbol there. You have silver, the moon, copper, Venus, iron, Mars, tin, Jupiter, Mercury, of course, associated with Mercury, lead with Saturn. I'm not sure exactly why the associations work, but these are all the symbols. And John Dee, who was a very strong proponent of this idea that alchemy and astrology went together, that they were part of this important for this holistic understanding of the world, he came up with this little design right here. If you look at it, he's combined every one of those symbols over here into one symbol, which I think is kind of cool. There you can see the sun, and of course you can easily see Mercury, okay? A little bit harder to see some of the others, like, let's see, Saturn, but you look here, you've got a crossbar, and then you've got this lower part here. You've got, kind of on its side, you've got this part here is Jupiter. Mars is the arrows down here. That's kind of weird. I mean, it's kind of cool, but he's not the only person who uses this. One of the people we're going to talk about in a moment used it very frequently. All right, let's talk about elements, because this, the way that alchemists thought about elements is very important to the development of alchemy. We, of course, have our periodic table of elements, and modern chemists would say, you know, an element is something we can't break down to anything simpler by chemical means. And that's an operational definition. Goes back to Boyle, and it was picked up by Lavoisier, who popularized it much more. But we can't break these things down, you know, to anything simpler by chemical means. And that's what we mean by an element. Of course, this arrangement is due to Mendeleev, who put this together in the 19th century. Okay. Most people in antiquity and in Middle Ages accepted Aristotle's view that there were four elements. There was earth, air, fire, water. Okay. Each of these had two qualities associated with it. Air had hot and wet. Water was obviously wet and cold. Okay. And if you talk about it, this actually implies if you could figure out a way to switch qualities around by some process, you could transmute these elements. Okay. If you, for example, you had fire and you switched from hot to cold, fire would become earth, and so on. You could switch all of these around. Now, the alchemists gave lip service to this, but more often they were adhered to another theory, which is referred to as the sulfur-mercury theory. Okay, there's sulfur, there's mercury. Now, the sulfur and mercury they thought about, these were kind of concepts. These were the closest approximation in the real world to the philosophic sulfur and mercury. Paracelsus thought we'd add salt as another element in here, but that's most of the alchemists adhere to at least to this concept. And how would it relate to the Aristotelian elements? Some of them thought, well, the Aristotelian elements combine in various ways to produce sulfur and mercury, which then combine to make, you know, various metals. Okay. So these came from Jabir Ibn Hayyan, maybe from, and this is a school of thought rather than a person. Derived from Aristotle's Meteorology, a lesser known Aristotelian work, where the earth, according to that, the earth produces dry, smoky fumes that's identified with sulfur, wet, vaporous fumes associated with mercury, and all the metals are just mixtures of sulfur and mercury in various proportions. So you should be able to transmute one into the other. And it was thought that actually took place in the earth, that's how you that the metals sort of grew and matured in the earth. Okay. Often because you could find things like silver and lead were usually found together in ore deposits. If one suggestion recently was to look at the lead pollution in cores from Greenland, and you could figure out about how much silver the Roman Empire had as their economic base. Okay. Because when they were smelting the ores, lot of the lead was going off as pollution. So the idea of the Philosopher's Stone or the elixir, it would heal the base metals. It would change the balance of sulfur and mercury, and you would get then silver and gold. Once they thought about that, they said, well, you know, if it can heal base metals, maybe it can heal other things. And so this was also then thought that this would be the Philosopher's Stone or elixir would be then a potent medicine. Could perhaps prolong life indefinitely because it would get rid of all illness. So you could work on finding purifying materials to get the Philosopher's Stone, that whatever little catalyst that would cause the changes in the metals, or it would also be something which would be a very powerful medicine. Okay, let me talk about alchemical procedures a little bit. If you go into the laboratory, what did you do? Okay, this is from the Summa Perfectionis, attributed to Jabir, or to Paulo Taranto, if you believe William Newman. And I just went through, I got a copy of the text over here, and I just went through the list of procedures that he talks about. Sublimation, you go from solid through vapor state to another solid. That's a purification. You can sublime things. You may be able to sublime things out of a mixture and then get a purified material. Dissension involves heating things on a grate, collecting the stuff that melts out. The other stuff, you get rid of the slag doesn't go through, and so you've separated out the stuff that you're interested in. Distillation, we're going to talk a little bit more about, but we're all pretty familiar with that. You take a solution, you distill it, you capture the stuff that distills over. That's the stuff that you're interested in. Calcination involves heating metals, and we would say that we produce an oxide. Solution, of course, is dissolving things. Coagulation is basically clotting things. I wasn't really familiar with terms fixation or ceration. Ceration actually involves mixing the materials with oils or waxes and things like that. Fixation is actually, we would consider it a form of distillation. The vessels for doing fixation, you're basically heating materials. You have your body of your vessel, and then you have this really long neck that goes up. Okay, and the idea is that the stuff gets heated, gets vaporized, condenses up there in the neck, and runs back down. Okay, that's called, we would call that refluxing now. So it's considered it's related to distillation. And so that's a technique that a lot of these techniques we carry over. Now the alchemists didn't invent a lot of these, although sublimation apparently was unique to alchemy. Apparently no metallurgists didn't use it. On the other hand, people had been distilling things for a long time before the alchemists got their hands on it. But they improved the technique. They made it more efficient, more effective. It was an alchemist who came up with the idea of using running water to cool the condenser in a still so that you got, so it was a more efficient distillation process. And here are some examples. This is from one of the manuscripts of Zosimus of Panopolis. Those are distilling rigs. Those are stills, okay? Showing different kinds of techniques. This is from a 16th century alchemical manuscript. These are all diagrams of different kinds of stills. Of course, nowadays we don't do that because it's against the law, most of the kind of stuff we would like to distill. But if you were, you ladies would be interested in this, the books of secrets for people running households was, it told you needed a bunch of stills. Why? Because you need to distill various kinds. You distill essential oils out of herbs and spices that are used for medication and so on. So running a household required that you had to have at least one still. Okay. Now, we'll talk about some of the things you get by distillation, and you can think when you think about it, these people realize this is really marvelous stuff. It's really fantastic what we can do. Take a dilute solution of alcohol, we can distill it. We get when we distill it, we get aquavita. By the way, the aquavit, that term persists, and that's a Scandinavian alcoholic beverage. Okay, that's ethanol. And think about how magic that stuff is. Okay, it inebriates us, that's really pretty cool. But also, it's a water that burns. Okay, it's flammable. Also, it will dissolve things. It will extract essential oils from herbs, something that water will not do, because the essential oils, being oils, won't dissolve in water, but they will dissolve in ethanol. So it was a tremendous tool for preparation of medications. We have a couple of other waters, okay? Aqua fortis or aqua valens. That's nitric acid. Now, why am I mentioning that in connection with distillation? Well, I'm going to explain in a moment how you make mineral acids by distillation. Another one, aqua regia. That's a term of art that's still used by chemists. That's a mixture of nitric and hydrochloric acids. Aqua regia means royal water. Why is it called aqua regia? Anybody know? It dissolves gold. Okay, that's the one thing that will dissolve gold. It actually you get a gold chloride complex ion. That's the thing why it will dissolve gold. Okay, so that's why that's kind of magical. You have oil of vitriol. It's not a water, but it's called an oil. That's sulfuric acid. Okay. By the way, that's where the term, we get the term, we talk about, a really angry, speech or writing is, vitriolic. Okay. It comes from the fact that, from sulfuric acid. Now I'm going to explain to you how you would make, if you had a still, how you would make sulfuric acid. It involves a dry distillation. This is actually Newton's recipe. We say this is Newton's own sulfuric acid. We put a label on it Paul Newman's own salad dressing or whatever. You start with vitriol, ferrous sulfate heptahydrate. Okay, it's called vitriol because its crystals are kind of glass-like, and they took the name from the Latin word for glass. Okay, so all this vitriol actually comes from glass. That actually goes back to the Latin word for glass. You heat that in a retort. You get ferrous sulfate and drive off the water. You ramp the temperature up. You add more charcoal. Start using bellows. The ferrous sulfate breaks down into ferric oxide. You get SO2. SO3 goes off. The SO3 combines with water that's in the atmosphere, and you get, coming over, sulfuric acid. Okay? And the reason it's called oil of vitriol, if you've ever seen concentrated sulfuric acid, it's oily. It looks like an oil. Okay? Clear once you start messing with it, it's not like any other oil. But how you can make nitric acid, just substitute saltpeter, potassium nitrate, for vitriol, and you can make nitric acid. Making hydrochloric acid is really simple. All you need is some salt, one of the other acids. You dump nitric acid, sulfuric acid on the salt. You trap the gas that's evolved, run that. You have a tube that goes into a water bath. The HCl is evolved. It's trapped in the water. You now have hydrochloric acid. You can make the 3 mineral acids. This is something that the alchemists of the Renaissance and the early modern period, they learned how to do. An alchemist, Johann Glauber, figured out how to produce sulfuric acid on an industrial scale directly from sulfur. And so then you could then go and buy bottles of sulfuric acid. I mean, if you ever wondered, how did they get the stuff they worked with? They couldn't just, send an order to Fisher Scientific or Aldrich Chemicals. I need 500 milliliters of sulfuric acid. You got to make it yourself, okay? But this is kind of clever, and you realize that they're distilling a lot of stuff out of this. And you can later on, people got methanol by distilling by destructive distillation of wood. So that's why it's called wood alcohol. Okay. Now let's see. We've talked a little what's going on in Europe. What's going on in the New World? Let's look at what's going on in New England. This is a very, very partial list of people who were known alchemists in New England. This is like half of them. Okay. You have officials. John Winthrop Jr. That's who that is right there. John Winthrop Jr. When when he was in his 20s, he came to the New World, came to New England with his father, John Winthrop Sr., who was the first governor of Massachusetts Bay Colony. When he shipped over, this was in the 1630s, he shipped over barrels of alchemical textbooks, apparatus, and chemicals. He went into mining and metallurgy. He had the project. He came up with the project of turning New London, Connecticut, into a center for alchemical healing. Now that never really took off, but he was mainly interested in preparations of medicines. He was a physician. He was elected without actually running for the office. He was elected governor of Connecticut. In what position he served for? He served there for 18 years until his death. And he's a very interesting guy because dealt very fairly with the Native Americans. Whenever there were witchcraft accusations, and he was in the colony, frequently went back to England to make trips for various purposes. But the witches were never executed when he was, in the colony. William Stoughton, on the other hand, some of you may recognize what name of William Stoughton. He's Lieutenant Governor of Massachusetts. Again, he's one of these iatrochemical alchemists interested in making medications. He was the head of the court of Oyer and Terminer that tried the Salem witches. Okay, we've got college presidents who were known to be alchemists. Okay, Charles Chauncey, Leonard Horst, Ezra Stiles. Anybody know what colleges they were presidents of? How about Chauncey, second president of Harvard? Leonard Hoare, third president of Harvard. He wanted to set up an alchemical laboratory at Harvard. Problem was he fell out with the student body and had to leave, which I suppose is good because then Harvard doesn't have a building named for him, like Whorehouse. Ezra Stiles was president of Yale. Okay, these people were big time into this. Okay, and now they also have an internationally famous alchemist, a man named George Starkey, who writes under the name of Irenaeus Philalethes. Okay. Let's tell you something about Starkey. Starkey's a major player in this in remarkable ways. He was born in Bermuda. His parents were missionaries. Their parents died, so he's an orphan. They decide he needs to get a college education. So there's this new place up there in Cambridge, Massachusetts called Harvard. We're going to send him there. Gets his AB degree in 1646. Harvard College was founded in 1636. Okay, he's in the first group of people who ever gets a degree. And he may have been tutored by Henry Dunster, the first president of Harvard, may have been his personal tutor. He said he got interested in alchemy because of a debate that they held at Harvard when he was an undergraduate. They had a debate on whether transmutation of metals was possible, and that excited his interest in alchemy. He started doing it on his own. The early surviving writing of his is a letter to John Winthrop Jr. requesting to borrow, can I borrow some glassware and some chemical and some alchemical texts that you have? After he graduated, he was a physician and alchemist in Massachusetts, went to London. He said he went to London because nobody in New England knew how to build the furnaces he needed for his alchemical laboratory. He was the mentor of Robert Boyle. When Robert Boyle came to write The Skeptical Chemist, he said, well, I was really lucky I didn't get contaminated with all these weird alchemical ideas because I learned my alchemy from illiterates. Okay? Yeah, his illiterate mentor could read and write English, Latin, Greek, and probably Hebrew. Okay? Was very well educated. There's a fascinating document that was uncovered recently. It's a page taken from one of Starkey's research notebooks. Scholars now have actually 3 intact notebooks belong to him, which is really fascinating, allowed to actually see the thinking of an actual alchemist. But this page is particularly important. Okay, the writing is in Starkey's hand. There are marginal notes and questions in the hand of Robert Boyle. Where was the document found? In the papers of John Locke. So this guy is so important that his alchemical writings, his notebook pages are circulating among the elites. Okay. He's also the author of what's called the Clavis or key. That is a key document in the new scholarship of alchemy. It'd be fair to say he was the most widely read American scientist before Benjamin Franklin. He published under his own name. He published under the name of Irenaeus Philalethes. He had Boyle and other people in England convinced that there was an alchemist in New England who wrote under the name of Irenaeus Philalethes. It wasn't him. He did, he was hiding his authorship. And they were convinced that there was somebody on the other side of the ocean who was writing all these alchemical texts. Which I think is kind of an interesting. I'd like to know some more about his psychology, why he decided to do that. Okay. All right. So, what did alchemy contribute to the scientific revolution? They obviously were doing a lot of stuff in the laboratory. They developed a battery or array of analytical techniques, which were very important, useful for chemical technology, important in developing other concepts like the principle of mass balance, the idea that the weight of reactants should equal the rate of products. And as soon as you start paying attention to that, of course it isn't always true, it is in some cases, but in oxidation reactions it isn't true. But you discover that pretty quickly, which the alchemists actually did when they start paying attention to mass balance. And then finally developed a corpuscular matter theory, the theory of matter made up of little tiny particles. Okay, so let's talk a little bit about techniques. This is just from Georgius Agricola de Re Metallica. Have silver ways of assaying different ores, and this involves actually calculating percent compositions. So you have to do very careful weighings. Now I think it's commonly, at least among the common thought about alchemists, is they just threw things together, weren't terribly scrupulous about weights and measures. They certainly weren't real careful to try to be very, very exact. Now this is a woodcut here from the 16th century. It's from an alchemical text. There's a laboratory. It's a little hard to see, but you can see the main thing here. If that were true, if they were throwing everything together, or they were just, kind of approximating, a handful of this, handful of that, what's that? Anybody want to guess what that is? It's not just a balance. It's a special kind of balance. It's a light beam analytical balance because it's in an enclosure. You put things in balances in enclosures when you have to weigh really tiny amounts of things so wind currents don't disturb the balance. So this is an actual analytical balance. This is 16th century, okay? So they've developed the tools that they need to do very, very careful work. Okay. Let's talk about Newton's Clavis now, where we're talking about weights and measures. This was published in 1975, again by Betty Jo Teeter-Dobbs. And it's a procedure for the preparation of an amalgam of antimony, mercury, silver, and gold. And it specifies weights of reagents and products and also specifies the proper way to carry out the various procedures, okay? And it was immediately attributed to Newton. It's in Newton's handwriting, it's in Newton's paper, so he came up with this, he invented this, okay? Dobbs said, one knows the lion by his claw, tumquam ex unguiae leonum. And Richard Westphal, who wrote one of the more respected biographies of Newton, Never at Rest, said alchemy had never known anything like this before. It was indeed more than alchemy could survive. That's actually a page. It's a 3-page document. That's one of the pages from the Clavis, or key. Okay. Now the problem is that recently, after this, William Newman published an article. He found in the correspondence of Robert Boyle a letter in the handwriting of George Starkey. And he can securely date it from content to 1651. It is word for word, the Clavis is in Latin, but the procedure, the Starkey letter is the procedure word for word. If you just translated the Latin into English, that would be this. You'd get what's in the text of this letter to Boyle. 1651. Well, maybe Newton. Newton came up with it first, and Starkey copied it. Anybody see a problem with that? 1651. Newton's 9 years old. He's a prodigy, but he's not that much of a prodigy. Newton got this letter, this important document showing about the emphasis on weights and so forth. He got it indirectly from Starkey. Now, Starkey may not have originated it, may have been passing it on from some other thing that he read. But right now, a source has not been found for that. So right now, he gets credit for this stuff that really impressed Newton enough for him to translate it and try the procedure out, presumably. Right. The emphasis on weights and measures really goes back to an alchemist, Jan Baptiste von Helmont. He founded pneumatic chemistry. First to realize that there were gases that were really different from air. He actually coined the term gas, took the Greek word for chaos, and that became the word gas. He emphasized mass balance in these reactions. He's very famous for one experiment where he grew a tree in a pot of soil, and he weighed the soil before he grew the tree, cut the tree, pulled the tree up, weighed the soil, and said, look, there's all this gain here in the weight. The soil hasn't changed, so the tree is gaining something. He thought it was water because he didn't know about carbon dioxide yet. Okay? But that's how the emphasis, he's really willing to carry on this kind of an experiment, look at weights and follow things through and see, look at reactants and products and look at their weights. Finally, we get to the corpuscular theory of matter theory. Basically, the idea is that the matter is composed of minute particles and that some of the properties of objects are really aspect of the way we perceive them. They're not really primary qualities. Colors and things like that can be considered to some extent secondary properties. Primary properties are things which really determine the secondary properties. And that elements can combine in different ratios to give compounds with different properties. And that the common way of tracing the corpuscular theory back is to say, well, it starts with Democritus, goes through the Epicureans. You have the poem by Lucretius, De Natura Rerum, on the nature of things, through to people like Paul Gassendi in the early modern period. What happens in alchemy, they go from Aristotle's meteorology through Jabir, the Summa Perfectionis, which implies the existence of these small particles, to people like Boyle and Newton. Boyle incorporates the idea of little particles in his mechanical philosophy. Newton, if you remember, thought of light as being composed of little particles. Okay? He thought everything was made of particles, including light. Okay? And there's a very important experiment that Boyle cited. Actually, he plagiarized it. He didn't give the source of this. This is an experiment done by reported by Daniel Sennert, who was a physician and alchemist. A lot of these guys were physicians and alchemists, and he had a number of publications here. That's a picture of him right there. Here's his experiment. This is called the reduction to the pristine state. You take a gold and silver alloy. The gold and silver alloy, that's electrum. Okay, you dissolve that in aqua fortis. Aqua fortis will dissolve silver. It will not dissolve gold. We're not dealing with aqua regia here, okay? You filter the solution. That recovers the particles of gold that haven't been dissolved. You're passing this solution through a very fine filter, and then you treat the filtrate with salt of tartar, which is potassium carbonate. You get this kind of creamy looking precipitate. You take that, you put the precipitate in a crucible, you heat it, you get droplets of silver. Okay? It says, look, there are little tiny particles that somehow know they're silver. Okay? They carry with them the property of being silver, or the property of being gold, or the property of being something else. So this is matter is really made up of these little tiny particles that have these properties. Now, think about this. We accept this notion pretty easily, but it wasn't actually. hasn't only been, people have only accepted it for a relatively short time, even in, it was not actually accepted completely even by the 20th century. Ludwig Boltzmann was the father of statistical mechanics. He was developing of the kinetic theory of gases, which basically say that there are these little particles which are banging into the walls. And so he advocated this atomic theory. Now what he ran into was when he tried to publish his articles where he's talking about the atoms or molecules banging into the walls and producing the pressure, the editors of the journal says, oh, you can only treat those as models. They're probably not, you can't treat them as though they're real, okay? They're just, they're some useful models, okay? That's probably why he committed suicide. One of the reasons he may have committed suicide. He also bipolar, but it didn't help him. And unless you think that the opponents were some sort of, quacks and cranks, here's one, Ernst Mach, Mach number, okay? I don't know that he ever converted, but he was a physicist, philosopher of science, but he opposed the atomic theory. He didn't think, he's still not, apparently thinking of matter being sort of indefinitely divisible. And Wilhelm Oswald, physical chemist, Nobel laureate. Okay? He's considered one of the fathers of physical chemistry. Again, an opponent of the atomic theory. Eventually, he changed his mind. What changed his mind was the publications, the explanations of the Brownian motion. The little particles hitting, things we could observe under a microscope and causing them to move around. And the mathematical treatment, which goes back really to Einstein. People think about, Einstein in 1905 published a number of papers, photoelectric effect, which got the Nobel Prize for, the special theory of relativity, and he published a paper on the Brownian motion. That would have got him into the books on the history of science by itself. He hadn't published anything else. Now, the physicists had to struggle with this, I have to say. The chemists, not so much. The chemists, by this point, by the beginning of the 20th century, we accepted, the notion of the existence of atoms and molecules, that they have real physical existence. They're stable structures. And so we'll get to that in a moment. But before we get there, we're going to point out that what happened in about the 18th century is that alchemy and chemistry just went off, parted ways. Chemistry went on to become chemistry. Alchemy was largely taken over by occultists. Ian Waite is known for a number of rather bad translations of important alchemical work. Unfortunately, for some important alchemical works, his is the only translations in English. Unfortunately, he basically corrupts the text by putting in all of his own esoteric occultist ideas. Okay. Another important figure is Ethan Allen Hitchcock, picture shown there, grandson of Revolutionary War hero Ethan Allen, U.S. Army officer. He was in the Seminole Wars, Mexican War, Civil War. He was lieutenant colonel at one point, lieutenant colonel commanding the 3rd Infantry Regiment that's over there at guards Arlington National Cemetery. During the Civil War, he was promoted the rank of Major General, and was important military advisor to Secretary of War Stanton and to President Lincoln. There's apparently at one point Stanton considered replacing George McClellan with Hitchcock, because he basically considered that McClellan was absolutely worthless as a field commander. I'm not sure that a person who is, into transcendentalism and interested in esoteric, makes a good combat commander. Okay. But anyway, let's now move to the chemist view of the world. Chemists accepted the notion of atoms and molecules, and I'm going to introduce you to Friedrich August Kekule. He was the principal formulator of the theory of chemical structure, originated the idea that carbon is tetravalent, involved in 4 bonds, and originated the idea of carbon-carbon bonding, which explains an awful lot of organic chemistry. This guy is a big, heavy hitter. He told his graduate students, you must learn to dream. And he actually claimed he made a major discovery from a dream. He was trying to figure out what was the structure of the compound with the formula C6H6. He had a dream of a serpent swallowing its own tail. Okay? This is the Oribus. That is one of the oldest alchemical symbols. He knew that it was an alchemical symbol. But this is the said he had a dream of. Now, I don't know whether he really had the dream, but he certainly claimed he had the dream, and he certainly knew that it was an important symbol. In fact, it goes all the way back to the beginning of alchemy. It's found in the manuscripts of Zosimus. This is the structure of benzene, of C6H6. This is actually from his actual article that he published. So the chemists were accepting all this idea. So that came, the corpuscular theory of matter that just kept on going into the 18th, 19th, 20th centuries, perfectly good. Now we have a handle on a lot of this stuff. Okay. We often talk, people talk about cold fusion in the context of supplying energy, but it involves the conversion of deuterium, which is a hydrogen isotope, into helium. That's an elemental transmutation, people, okay? And actually, Louis Alvarez was able to observe muon or mu meson catalyzed cold fusion, low temperature, don't have to have it, really high temperatures to jam the things together. And Pons and Fleischmann said that they did this in a cell with a palladium electrode, that they just pushed you could get the saturated with deuterium, and they could just push the atoms together, and they would coalesce and fuse, and they survived it, which they shouldn't have, because they should have given off all sorts of neutrons and irradiated anybody in the lab to death. But this, people still believe this is possible. Okay, and to show you what I mean by it's possible, this is from the cold fusion article first showed up in 1991. This is from Science in 1995. John Bachris, who's a senior professor at Texas A&M, he starts doing research on transmutations of base metals into gold, okay, and says it's probably possible, okay. This leads to 11 full professors in his department signing a letter saying, we want him to resign. He is disgracing this department, okay? But this is a guy who is, he's an electrochemist, and he's a friend of Pons and Fleischmann. So, he doesn't believe it's necessarily impossible. The problem is you got these energy barriers to get over, and that's the trick, okay? Okay. Now, let's talk a little bit about books. We can give the modern spiritual alchemy. You can get your own copy of the Emerald Tablet if you want. Actually, it's available online. You can even find Newton's translation, so you can read that. I like this one, Idiot's Guide to Alchemy, the ancient craft revealed for today, knowledge of higher worlds, and so on. However, there is a real transmutation that's taken place. This is the original title of the first Harry Potter book. It's Harry Potter and the Philosopher's Stone. In this country, it was changed to Harry Potter and the Sorcerer's Stone. And that was, I think, the title of the movie. Okay? But it was actually Philosopher's Stone, and actually mentions people like John Dee. Okay? And she was able to turn paper and ink and to transmute that into a huge pile of gold. A really, really big pile of gold. Okay, let me give you some suggested reading if you want to read more about this. These are some interesting books. Some of them are deeper than others. The Homeyard book is fairly old. It belongs to the older scholarship. But it tells all the scabrous and scandalous stories about alchemists. A lot of good color, okay? Principe, Secrets of Alchemy came out a couple of years ago. It's a really nice, summary of the history of alchemy, and it hits the important people. Newman's written Atoms and Alchemy, which really focuses on 17th century alchemy and their corpuscular theory. It's fairly deep. Okay, it gets into, and Bruce Moran's Distilling Knowledge. That's also a very good book, and this doesn't get as deep as Newman's Atoms and Alchemy. But those are ones you can pick up pretty easily. They're still in print, and they're actually fairly. Most recent one is this one. This is the Chemistry of Alchemy. It's just hit the bookstores. I got my copy a couple of months ago. Basically, how chemistry was forged is from dragon's blood to donkey dung. They use fermenting donkey dung as a source of mild heat, by the way. And it actually has recipes, so you can actually go into your kitchen and you can become an alchemist. And I actually did that. I actually took one of the recipes for the creation of what's called the Tree of Diana. And what you do is you take copper wire, you can shape it in various ways, you take copper wire and you dip it into a solution, a dilute solution of silver nitrate. And you get this, something that looks like foliage growing on the wire. And I actually did that. That's not a good picture. There's the copper wire right there. This is underneath the water, this kind of fluffy looking stuff, and that's looking at it close up. It looks like leaves on a tree. They're crystals of silver that have been deposited there. What's happening is the copper is giving up electrons and giving them to the silver ions in solution. Silver ions are precipitating out as metal, and now and this will continue to grow because the silver crystals conduct electricity, so the electrons can get out there to the solution pretty easily, and you get this very nice kind of fluffy kind of stuff. And if you take that, you test it, you do an assay on it, yeah, it's silver, and you could probably scrape it off and put it in a crucible, heat it, and fuse it into little droplets of silver if you wanted. The centered experiment, I should have mentioned when I was talking about that, about dissolving the silver and in the gold, silver and gold alloy, running it through a filter, and then reprecipitating the silver compound and heating it. When I was a teaching fellow, we did that experiment. We left out the filtering part. What we did is we took a common U.S. dime, which contains a lot of copper. We dissolved it in nitric acid. We precipitated out the silver. You didn't have to filter it because you don't have, the copper stays in solution. Precipitated out. The students then collected the precipitate, put it in a crucible, heated it with a blowtorch, and there you had a little button of silver that they could take back to their dorm rooms. Go take it home and say, look, Mommy and Daddy, this is what your $50,000 a year bought. Okay. A couple of websites. There are actually a number of the interesting websites, but I want to point you to a couple of them. This is actually at Indiana University, hosted by William Newman. It's the Chemistry of Isaac Newton. A lot of links to original sources, original alchemical texts. Shows you how you do mineral acids. Shows the results of some of these experiments. Nova did in 2005. Nova did a show on Newton's dark secrets about his theological writings and his alchemy, and this is still available. You can go online and you can see it. Okay. Questions? Yeah. Yes, Scott.
It sounds to me, are you characterizing the correctness of the corpuscular theory of matter?
Well, they were groping toward what we now accept as modern science.
Was it just a lucky insight, or did they actually get some sort of feedback from their work of, this does seem to fit like a primitive science?
Well, that's kind of how Boyle took the Sennert's experiment. That's the way he interpreted it. That means that matter is made up of little particles that carry with them certain properties or qualities, and he's interpreting the actual experimental results in terms of here's the way the experiment works, and this is what it looks like it means, and interpreting it that way. And so he's drawing conclusions from the actual experiment. I said he plagiarized that. He mentions it in The Skeptical Chemist, but he doesn't give the source, although from other evidence, he had read Sennert's work. So he's probably just stealing it. So he sometimes was a little bit less than we consider a ethical modern scientist. But he statements about the people who taught him alchemy. Have been accepted at face value by many people, by many historians of science, and it's absolutely untrue. Yeah.
Just kind of a follow-up to Scott's comment. The issue might have been for physicists that continuum mechanics, like fluid mechanics and stuff like that, treated these types of media as continua. Yeah. And the notion that, they could actually be really, 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 really tiny particles was still something.
And see, the chemists by the middle of the 19th century their view of molecules was that they represent stable structures. They're three-dimensional. They have to be three-dimensional because we have optical isomers. And that goes back to Pasteur, to his separation of D and L forms of tartrate crystals. But that meant that you can only have optical isomerism if you have three-dimensional, if your molecules are three-dimensional. So they'd already accepted that. And by the and the work of people like Kekulé and these people are, they're saying we have these structures. We can draw chemical structures, and this is what these things are really like. Okay, we've already accepted that. We know that to be the case. Yes.
Would they sell alchemy sets the way they would sell chemistry sets? The forerunner would be kind of interesting.
It would be interesting. I don't think they ever did. The closest I ever, people did when microscopy began to develop. People would buy microscopy setups for their country homes, and they actually used sunlight piped in through a window, take out a window pane. They had a microscope that actually fitted in there, and they could project the images of the slides on a wall and stuff like that. But I don't think if they did anything like that there was no I don't think there was anything analogous to chemistry sets in alchemy. It would have been kind of fun to do it, but you probably some of the young people got into it pretty early. I suspect Starkey did, and he was when he was an undergraduate.
There'd be some kind of crossover, wouldn't there?
Early
Would you have?
Yeah. Well, actually, a lot of I mentioned a lot of these people, alchemists are physicians. The way that chemistry typically got into the colleges, universities, was through the medical schools, compounding medicines. Okay, it wasn't until the 19th century that the arts and sciences parts of colleges began to offer courses in chemistry and have chemistry laboratories. Harvard was back in the 17th century they were going to set up an alchemical laboratory. Well, the first time they actually came close to that is they set up the Lawrence Scientific School in the middle of the 19th century. And actually Charles Sanders Peirce, the philosopher, was one of the first people to get a degree in chemistry in the United States. Part of it has to do, I think, I always think it's kind of a prejudice. The chemists, we work with our hands. We're grubby people. We create stinks and bad smells, and we're artisans. Chemistry comes from artisans. Okay, and so I think that there was a good bit of prejudice against chemistry, introducing chemistry into. People talked about things, transmutation of elements and stuff like that. But the idea of having chemical laboratories was, they really didn't want to go there for a while. Yeah.
Is it fair to say that in the 16th and 17th centuries, then, that this alchemical worldview is not fringe; it's really mainstream?
Yeah, it is the mainstream. It's what everybody believes. You can see that in some of the books that were just written about what the world is like Charles Morton's book, the textbook that he wrote for use at Harvard College, and it was the late 17th century. But this is the way we understand the world. This is the way the world is, the way we understand it, and everybody's interested in it. Okay, it's the interest is from top to bottom. When you got got a king of England who's got an alchemical laboratory. That isn't just he's not necessarily a dilettante. And you have people funding this. There was a talk about, I just had a very brief mention of John Allen, the radical Protestant minister. He was Starkey's roommate at Harvard. And he went back to England, and his correspondence talks about setting up an alchemical laboratory at Oxford as part of the university. Okay? And there was a circle of people at Oxford who were very interested in alchemy, and they would have really bought into it, but it never happened, unfortunately. I think having some people put some big-time money and some real brains behind the endeavor. Newton working by himself was probably not the optimal way for alchemy to develop into chemistry. You need a lot of inputs from different people with different knowledge and skill. Yeah.
So at what point does sort of the experimental approach really get in there?
Well, they were beginning to do that certainly by the certainly by the 17th century, because Starkey's research notebook, it's fascinating reading because they've got, here's the literature review, okay? Here's what the texts say about this, okay? Here's my proposed set of experiments, okay? Here are the results of the experiments that go further on in the thing. Then he goes back and he puts marginal comments on his ideas. He sometimes will go through and cross out, things that didn't work out. He does never completely, you can still read them, but he does like we do now, is we cross it out and say that's bad. He has one occasion he puts in the margin, this is silly, and he often says this is tried in the fire, didn't work. Okay, people began to say, the real arbiter of truth here is what happens in the laboratory, what we can actually do. And remember, I said that these historians of science, this historian of science said, alchemy wasn't something you believed, it's something you did. And that became the arbiter. We can go into the lab, we can do these things. The amount of experimentation that was going on was really enormous. And you look at some of the books that more, like in metallurgy and mining and things like, these people are doing a tremendous amount of work. And they're very careful. You claim this is gold. Well, I've got some tests over here that will test whether it's gold or not. So I've got ways of testing this, and we can test the outcome of our experiments. So, and in case of Starkey, very carefully observed. He was a very, very careful worker. He derided the education he got at Harvard College. He's kind of like, like Faust. All this stuff all these philosophers I've learned, this is just useless, okay? But the fact is that educational experience, which was based on medieval scholasticism, it molded his mind. He knew how to read a text, how to analyze it, and how to attack it in an orderly fashion, and that shows throughout his notebooks. That's why they're so fascinating, because it's a rare occasion where you've got the actual research notebooks of somebody working in that period, and you think, this stuff is. He's got a clear. He was interested in doing things like finding more efficient, more effective, and more economical ways of doing things. He's almost like doing industrial chemistry. I want to make this, but I want to find the most economical way to get there. And that's very, very often the way that his experiment program works. I know where I want to go, and I want but I want to be more efficient. I want to be more take fewer steps, do more economic, less expensive materials, and so on. So these guys were very much into. His notebooks look like what a good graduate student would produce today. They're careful, very orderly, showing a lot of orderly thinking, very detailed. You can reconstruct. In fact, if you want to, I didn't put it up there, but Newman and Principe have produced a critical edition of Starkey's notebooks. So you can go and this is what he's doing. So explain this is what he's doing here. This is what's step by step. This is what he's doing, and it's a very impressive body of work. Unfortunately, in his case, he died of the plague in 1665. You may remember that plague is a very seminal event in the history of science, because they close the universities, and Newton goes to Woolthorpe, and while he's down there, I'll invent calculus, and I'll invent optics, and I'll, with the law graph, laws of motion, I have nothing else to do, just sit under a tree and have an apple fall on my head, that was a great event. Unfortunately for Starkey, he didn't, he claimed he had a cure for the plague, was willing to stay, I guess, and try it out, and he died, killed him. Any other questions? Two more? Yes.
I'm trying to figure out the relationship between modern chemistry and alchemy. Are you saying that alchemy really enhanced the desire to have chemistry?
Well, they didn't know that chemistry existed. They had to get there. What I'm saying is that the techniques that are now part of chemistry came from alchemy. There's the techniques, the methods. the sublimation, we use that. Distillation. I was just talking to an undergraduate student who's doing some research with me yesterday. And he said, well, the first thing, I just had our first organic chemistry lab, and the first thing we did was the distillation. Okay? All that technology carries over, becomes part of the toolkit of the chemist. Okay? And certainly the alchemists were thinking in terms of little tiny particles that have certain kinds of properties. That carries over. The chemists just carry that over. They just elaborate on that. They add things. What happened in the 18th century was they discovered oxygen and realized that oxygen played a role in combustion reactions. Okay? But they are we take it now as a given. Yeah, the chemists are saying, yeah, everything's just a little particle. Well, there's a corpuscular, the little corpuscles that make up everything, and they're responsible for all these properties. So those ideas just go right on through. Okay, they become elaborated on as people do more experimentation. They say organic compounds, they have 3 dimensions and so on. They learn more and more, but they have a starting point, and this is kind of the starting point. This is not some crazy pseudo-science. These people they have ideas about what matter is composed of. They have experimental toolkit. So far as we can see, and certainly in the case of Newton, and certainly in the case of Starkey, they have an experimental program that they're going to pursue. They pursue it in a rational manner, okay? And the results of the experiments are the arbiters of the truth. So it's an experimental method that becomes ingrained. Okay. One more question over here. Somebody?
You mentioned Nicholas Flamel. I know a character from Rowling's book of Harry Potter stories. I thought he was a fictional character, but he's a real person. Can you tell me more about it?
Well, he was supposedly an alchemist, but all the alchemical works attributed to him are not by him. So, Flamel, the alchemist, is a fictional creation. He's not one that I've spent a lot of time really looking at. But Dee is also mentioned in the Rowling book as well. So, she had her ear to the ground. She knows about a lot of this stuff. She's one of these people like Shakespeare is like a mind like flannel. Everything sticks to it. Yeah.
Thank you very much.
Thank you.